All right, Mr. Ahmed here for 9.5. Goal for today is going to be the sine and cosine ratios. For these bell work problems, hopefully you guys would just push pause here if you haven't already done them and work on numbers 1 through 3, which is a review of the tangent ratio. I'm just going to show you the answers for those so you can check your work. So there's number 1, 2, and number 3. If you rounded to the 10th instead of the 100th, that is fine. The directions didn't say to do the 10th, but I typically just kind of go to the 100th. All right, so on to our new material for today, which is going to be the sine and cosine ratio. And we are going to use the sine and cosine ratio in right triangles to find missing sides. So the sine is equal to the opposite over the hypotenuse. So again, our reference angle has to be one of the acute angles. In this diagram, we're using angle A as our reference angle. And the sine of A is equal to the opposite leg divided by the hypotenuse. So that'd be BC over AB, opposite over hypotenuse. The cosine is equal to the adjacent leg over the hypotenuse. So in this process, we now have 3 trigonometric ratios that we can use. We have sine, cosine, and tangent. The mnemonic device that I use to remember these is called SO, CA, TOA. So I can write that down and come up with how these always look. S stands for sine. Okay, so sine is equal to opposite over hypotenuse. Sine opposite over hypotenuse. In a similar manner, C is cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Excuse me. And that is the mnemonic device that we can use to remember these. So if we write down SO, CA, TOA, we could just say how we have to set all these up. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. Keep in mind, we're always using an acute angle as the reference angle. We cannot use the right angle as the reference angle, because if I were to use the right angle as the reference angle, the opposite piece is the hypotenuse. So it just doesn't work out. We always have to be looking from an acute angle. So first example says find the sine of S. So sine of S equals. Now when I do sine, I have to remember sine is opposite over hypotenuse. So for here, S is here, so opposite is 63, and the hypotenuse is 65. Keep in mind, the hypotenuse is always opposite the right angle. The hypotenuse does not change. The opposite and the adjacent can change based off the reference angle. The next one says to find the sine of R. So now when I look from R, my reference angle is changing. So the opposite is 16 over the hypotenuse is still 65. So 16 over 65 for the sine of R. Now for the next one, I'm supposed to do cosine of S. So cosine of S. So I think cosine Ka equals adjacent over hypotenuse. So from S here, the adjacent piece is 16 over 65, and the still have to do sine of S. So I did sine of S, sine of R, cosine S. I still need to do cosine R. Couldn't remember which one I hadn't done yet. Cosine of R. So now when I look from R, Ka, adjacent, 63 over the hypotenuse, 65. Now it says that we're supposed to get a decimal rounded to 4 places for these as well, so I did have to use a calculator for that. And for me to get the decimal, I just need to divide. So I am looking at 63 divided by 65. That's 0.9692. Now here, 16 divided by 65, 0.2462. All right. And 16 over 65, I just did that. Same thing. 0.2462. And 63 over 65 is 0.9692. So I found them as both the decimal and the fraction. Key is looking from the reference angle. All right, next step, finding some missing side lengths. So again, we have to choose the angle that we're looking from. In this case, 26 is given, so I'm going to use that as the reference angle. So now, since I'm only using one reference angle, I'm going to label in our pieces as from here. This is opposite using an O. We'll go PP. The hypotenuse is the longest side across from the right, and Y would be the adjacent. So we have to set up two different ratios to find both X and Y. First, I'm going to find X. I just chose to do that one. So when I need to find X, X is opposite, and I have to use the other piece I know, which is the hypotenuse, 14. So I have to figure out which ratio is opposite and hypotenuse. So I'm going to write that down. So, toa. So opposite and hypotenuse, O and H, is sine. So I'd use the sine ratio. Sine of the angle, 26, equals opposite X over the hypotenuse, 14. Put it over 1, and we can cross multiply to solve. So X is equal to 14 times the sine of 26 degrees. Need to use my calculator for that. So 14 times sine 26, close it, and I get X to equal 6.1, because I'm supposed to round to the 10th. If you want to go to the, we'll go follow the instructions. 6.1, going to the 10th. So I didn't actually show that. 14 times sine 26 is 6.1. Now, other piece, Y. Y is adjacent. I still want to use the whole number. I'm using my 14. So adjacent and hypotenuse is the C ratio, A and H. So we're going to use cosine of the angle, 26 degrees, equals the adjacent piece over the hypotenuse. So that's Y over 14. Then I would cross multiply to solve, put it over 1. So Y equals 14 times the cosine of 26 degrees. And then I need my calculator to figure that out. 14 cosine 26. Y is equal to 12.6, setting around to the 10th. And we found our two values. All right, on to the next one. Go ahead and hit pause and give this one a shot. Okay, give this one a shot. All right, hopefully you had some success. Reference angle 65. Okay, so we're going to use that. We're going to label in our pieces then. T is opposite, U is adjacent, and 8 is the hypotenuse. All right, now we have to determine which ratio we're going to use. I'll find T first. So O and H. So, ka, toa. O and H are the two that we're using, so we'll use sine. So the sine of 65 degrees equals T over 8. Opposite over hypotenuse. Put it over 1, and we'll cross multiply to solve. So T is equal to 8 times the sine of 65 degrees. And I need a calculator for that. So 8 times the sine 65. 8 times sine 65 is 7.25. So 7.3. Rounding up. 7.3. On to our next one. Gonna find U now. So U is adjacent. We still want to use that whole number. So A and H, adjacent and hypotenuse, is the cosine ratio. So cosine of the angle 65 equals U over 8. Put it over 1, and we will cross multiply to solve. So U is equal to 8 times cosine 65 degrees. Take out our calculator. 8 times cosine 65. And we get 3.38, so 3.4. And we found our two missing pieces. Alrighty. For these problems here, I just need to find one missing side length. I think I'm going to do the first 8, and we will leave the other ones for in class. All right. So this is kind of going to be a extra practice here. So reference angle's 27. We're going to go with my SOHCAHTOA written down on the top. SOHCAHTOA. which ratio will I use? So from here, from the 27, x is O, opposite, 10 is adjacent. So which ratio is opposite and adjacent? That's the tangent ratio. So we have to use tangent this time of the angle 27 equals x over 10. Then we put it over 1, 2, cross multiply to solve. So x is equal to 10 times tangent 27 degrees. Using my calculator, I get 10 times the tangent 27 to be 5.1. All right, next one. Identify the reference angle again. 25 is the one we know. X is opposite, 10 is adjacent. O and A, tangent ratio again. So the tangent of 25 equals x over 10. Put it over 1, cross multiply to solve. So x is equal to 10 times the tangent 25 degrees. And when I type that in, I get 4.66, so 4.7. All right, go ahead and hit pause and give the next one a try, or however many you want to give a try, and then you can check back in for the solutions. All right. Hopefully you had some success. Reference angle's 39, going from there. So we have the opposite piece being, the adjacent piece is x, it's connected, and the hypotenuse is 7. So A and H is the cosine ratio. So we're going to use cosine of the angle 39 equals adjacent x over the hypotenuse 7. Put it over 1, cross multiply to solve. At this point, I'm kind of hoping you have the cross multiplying piece down, so I'm just going to type in 7 times the cosine of 39, and we got 5.4. On the next one, from the 46, 8 and x are the two we're working with. We aren't worried about this side, we don't need it. So opposite and hypotenuse, across hypotenuse. O and H is the sine ratio, so sine 46 degrees equals the opposite piece, 8 over x. Now, cross multiply to solve again. Hopefully you've kind of caught on to the pattern here where x is in the denominator, I have to multiply by x. So I am going to have to take 8 divided by the sine of 46. And I get 11.1. So just as we kind of see this, x times sine 46 equals 1 times 8 is 8. So to isolate the x, we still have to divide by the sine 46 both sides. Okay, so after we've done that a few times, we probably catch on to the pattern. All right, number 5 coming up. Reference angle is 23. Opposite, adjacent, O and A is the tangent ratio. So tangent 23 equals opposite, x over 6. Opposite over adjacent for tangent. Put it over 1 and we will cross multiply. So x equals 6 times the tangent, 23. So I'm just typing in 6 times tangent 23 and I get 2.5. On to the next one. Reference angle's 46. Opposite, adjacent, tangent of 46 equals 7 over adjacent x. Put it over 1 and you'll cross multiply. Like I said, if you need help on the cross multiplying piece at this point, go back, watch some previous examples, all right? So we're gonna have to divide. 7 divide tangent 46, and we get 6.8. And 2 left. Reference angle 72. Opposite, adjacent. O and A, tangent. 72 degrees equals opposite x over adjacent 20. Put it over 1. We'll cross multiply to solve, and when I cross multiply, I get 61.55. So that'd be 61.6. And our last one. Reference angle is 54. X is connected, so that's adjacent. 12 is the hypotenuse. A and A, cosine of the angle 54 equals adjacent x over the hypotenuse 12. Put it over 1. Cross multiply to solve. So 12 times cosine 54 is 7.1. All right, and that's all we got. The other page of examples here will kind of be used for during class, things of that nature. And if you need any further examples, these are ones that you can check with. I'm just going to quickly write down the answers here so you can check your work. I'm not going to explain how to do every one of these out loud. So 40, opposite, hypotenuse, using sine. Sine of 40 equals x over 19 when I solve. 12.2. Here, 31's the reference. Opposite, adjacent, using tangent. 31 degrees equals x over 10. Put it over 1, and we'll cross multiply and solve. So 10 tangent 31. You should get 6 for your solution. All right, number 11. 38 is my reference angle. Opposite, adjacent, tangent of the angle. And when I solve, solution is 25.6. So these are just your extra practice ones, all right? Reference angle here has to be 74 here. Adjacent, hypotenuse, cosine. 74 equals the adjacent piece, 19 over x. When I solve, get 68.9. And there's 2 more here for you to try. Opposite, hypotenuse, sine, 16, oh, I wrote 2 ends. Sine 16 degrees equals x over 18. Final solution. This rounds up to 5. 9 rounds up to a 5. And our last one, opposite, hypotenuse. Sine 40 equals x over 20. X equals 12.9. All right, that's all we got. Have a good one.